Macam hal.
Eddie.
Dia dah so cakap
Saya
benda
nak
ni.
set
Macam hal.
timer.
Ciao.
Okay, the
Macam
recording
hal.
has started.
Mhm.
Assalamualaikum warahmatullahi wabarakatuh to everyone. So today we are going to present our project, which is RROP, if I'm not mistaken, isn't it? Yeah, really
Yes.
route optimization problem. So in this project, we are from group. Sorry, we are from group one. We are going to present our project. Uh, so all the algorithms included as well. So starting with me, greedy algorithm. So what is greedy algorithm? As you may know, it's a optimization technique that solve a problem in stages by making the choice that appears to be the best in this project without regard for future consequences. So to function, a problem must possess the greedy choice property, meaning a globally optimal solution that can be achieved by a sequence of locally optimal choices and an optimal subtraction. So basically, the greedy algorithm is fast and simple to implement. It is also often found a near optimal solution in scenario like fractional knapsack problem or whatever. When finding the shortest path between what we say the Dijkstra's algorithm. So that's all for greedy algorithm for this project. Let's move to next part, divide and conquer.
So, hello everyone. So, for my part in divide and conquer. So, divide and conquer, it would help by breaking the large route searching process into smaller subproblems, exploring them, and then combining the results to get the optimal route. Okay, so basically, this divide and conquer, it would visits all ports exactly once, returns to the start, and calculates the total distance for each possible route. So of course, it would keep track of the best route and the lowest total cost found so far. And so by using divide and conquer, there is a branch and bound optimization. So um, before exploring a branch, um, divide and conquer, it would check the current cost. If it is already higher than the best cost found, and then we would skip that branch lah. Okay, so in conclusion, divide and conquer TSP implementation works by exploring all possible routes, pruning expensive paths, using branch and bound, and ensuring that we find the shortest and most efficient relief route. So this method suits RROP because it handles complexity well and guarantees optimal results. Okay, so that's all from me. Moving on to the next method.
So the next method will be dynamic programming. So what is actually a dynamic programming? Dynamic programming is a method for solving complex problems by breaking them down into simpler overlapping subproblems like backtracking. But unlike backtracking, it solves each subproblem only once and stores its result, allowing it to be efficiently reuse that solution whenever the same subproblem is encountered again. This algorithm is more useful in RRP because unlike greedy algorithm that might just go to the next closest spot that but didn't get the best route overall, or like backtracking they can find the best route overall but it take longer time to find. So how does dynamic programming work in the coding? Dynamic programming is just like a backtracking but a smart solution. It's find every possible path using a recursion but use a technique called memoization to be efficient. As we can see in our coding, we use a memoization array. This is like a memory. When we calculate the shortest path for the small piece of the journey, like the best way from C to A, having already visited B, we store the answer. If we need the exact answer again, we don't recalculate it. like backtracking. We just look it up in our memorization table. So why this algorithm is the best for ROP? This algorithm is the best for ROP because this method guarantee that we find the shortest optimal possible route in the ROP. And for a relay mission, this is really important. It means that we use less fuel, faster delivery time, and more efficient operation when every minutes count. So that's all. So that's only for my part.
All right, hi. So I'm going to explain the backtracking algorithm and how I apply it to the real life road optimization problem or RROP in our project. So when I first start implementing backtracking, I feel a bit challenged because I had to think about all possible routes and ensure my recursion will work correctly. And however, as I code, I started enjoying the process of systematically exploring every part and seeing how the algorithm could find the optimal solution. So I use backtracking to explore all possible solutions step by step. In the context of RROP, I systematically check every possible route for the relief visual visiting all ports exactly once and returning to the starting point. So if a certain part cannot produce a better solution than the current best, I backtrack to try another path. So this ensure I always find the optimal route, though it can be slower for large number of locations. So as you can see now in my Java code, I implementing backtracking with two main methods. So backtracking TSP and the recursive helper TSP backtracking. First, I initialize an array visited to keep track of which ports have been visited. Starting from port A, I use the part variable to store the current row as I explore different options. While writing this, I feel satisfied seeing my path building logic come together step by step. Inside TSP backtracking, I use recursion to visit each unvisited port. For each candidate port, I mark it as visited, append it to the current path, and calculate the cost of going there. Then I call the function recursively to continue exploring the next port. So when all ports are visited, I did, sorry, wait. When all ports are
Just
visited,
continue. Just continue.
when all ports are visited, I add the distance back to the starting port to complete the cycle. During this process, I keep track of the minimum cost road found so far. If a part does not lead to a better solution, I undo the visit, and this is the backtracking step and try another road. And I feel a sense of accomplishment when I realized the algorithm correctly avoid unnecessary path and efficiently found the best road. Finally, finally, after exploring all possible routes, my program returns to the shortest path along with its total distance. For my example, the optional route I found is port A to port B. Proceed with the real life center D, real life center C, and goes to port A with a total distance of 88 nautical miles. So in conclusion, backtracking allow me to find the exact optimal route for relief delivery, ensuring efficiency in time and resource. While it can be computationally intensive for many parts, and I feel proud knowing it guarantees accuracy, making it a reliable choice for humanitarian logistic operations. So that's all for me.
So moving on to the binary search and decision sort, searching is simply the process that is related to the information. We are dealing with the massive data set inside for web planning, like our organized distress matrix or list of visible routes. We cannot afford slow methods. So for insertion sort, the data must be sorted. For that, we turn to sorting, which arranges data into a specific order, like descending distance. Sorry. we, it works by taking one element at a time and inserting it into a correct position within the already sorted part of the list. While insertion sort can be slow for very large amount of data, the core concept of sorting is indispensable. It allows us it allows us to prioritize decisions. So In conclusion, sorting prepares the battlefield and binary search allows us to instantly locate critical information on that battlefield, making the entire ROP solution feasible and fast. So that's all for binary search and insertion sort. So let's move to the output of the coding, please, before we run out of your time. It's only 10 minutes, 8 seconds. So this is the output we expect it to be like in that question. So no problem as of now. So that's all from us, group one. Thank you.
Thank you.
Thank you.